Hello students. Have you ever wondered how engineers get brilliant ideas for designing cars, buildings, medical devices, or even advanced materials? What if I tell you that one of the world's greatest engineering has been solving problems successfully for more than 3.8 billion years? Yes, that engineer is nature itself. And today's topic is bio-inspired design, one of the most fascinating concepts in biology for engineers. The central idea behind bio-inspired design is very simple. Instead of inventing everything from scratch, engineers observe nature, learn from it, and apply those lessons to solve human problems. That is why people often say Mother Nature is the mentor. Nature has already tested countless designs through evolution. This design that survived are efficient, sustainable, and high optimized. Engineers try to study these natural systems and use them as models for developing new machines, materials, products, and technologies. This concept is often called as biomimicry, which literally means imitating life. But here, where most students get confused, you'll often hear three similar terms: biomimicry, biomimetics, and bionics. Although they are related, they are not exactly the same. Biomimicry focuses on imitating nature's designs and ideas. Biomimetics is more about accurately replicating structures and mechanisms found in nature. Bionics apply biological methods and systems that engineering designs and technologies. It often involves creating devices that replaces or human enhance human body functions. A simple example is a bionic arm or a bionic eye, where engineering combines with biology to restore human capabilities. Now, many students think biomimicry is a completely new concept. Actually, it is not. Humans have been learning from nature for thousands of years. Earlier, shelters resembles birds' nest made from branches and natural materials. The difference today is that modern technologies allow us to study nature in much greater detail and apply those findings on a large scale. Now, this leads us to the next important concept. How do engineers actually use nature to solve problems? There are two major approaches. The two major approaches are design to biology to design. The first approach is called design to biology. In this method, engineers first identify a human problem and then search for organisms that have already solved a similar problem in nature. A famous example is the Mercedes Benz Bionic car. Engineers wanted a vehicle that was more aerodynamic and fuel efficient. They studied the shape of the box fish and discovered that its body structure provides excellent flow characteristics. This natural design inspired the vehicle's shape. Similarly, tree growth pattern inspired the material efficient structures because tree uses minimum materials while maintaining the maximum strength. The second approach is the biology to design. Here, the process starts with biological observation rather than an engineering problem. Scientists first observe an interesting natural phenomenon and then explore how it can be applied in technology. One of famous example is the lotus flower. Even though it grows in muddy water, its surface remains clean. How scientists studied this how Scientists studied the self-cleaning mechanisms and developed potassium paints which can clean themselves when exposed to rainwater. And this is exactly why the next concept is important. These two approaches, like Mercedes-Benz and Lotus Flower, these two approaches are closely connected to top-down and bottom-up methods. When engineers started with a technology problem and searched for the biological solution, it is called top-down approach. When scientists began with biological discoveries and later find engineering applications, it is called the bottom-up approach. Now let us move to the one of the most important exam topics, the principle of biomimicry. This was asked when I was writing my exams. Janine Beines proposed nine basic principles. The principles are: nature runs on its own. Second, nature uses only the energy it needs. 3. Nature fits form to function. 4. Nature recycles everything. 5. Nature rewards cooperation. 6. Nature depends on diversity. 7. Nature demands local expertise. 8. Nature controls excess from within. 9. Nature taps the power of limits. These principles teaches engineers valuable lessons. Now let us go the meaning of these principles. Waste should become a resource. Energy should be used efficiently. Optimization is better than maximization. Material should be used sparingly. Resources should not be duplicated unnecessarily. Systems should remain balanced with the biosphere. These principles form the foundation of sustainable engineering. Now let us look to the another important concept. Nature can be viewed in three different ways. First one, nature as model. Here we study natural design and use them as inspiration for solving human problems. Second, nature as measure. Nature provides standards for evaluating whether our innovations are environmentally responsible. Third, nature as mentor. Instead of treating nature merely as a source of raw materials, we learn from its wisdom and long term survival strategies. Remember this statement because it is frequently asked in exam. After 3.8 billions of evolution, nature has learned what works and what hurts. Next, come to the levels of biomimicry. At the organism level, we imitate the form or shape of an organism. At the behavior level, we imitate process and action performed by organisms. At the ecosystem level, we imitate the functioning and interactions of entire ecosystem. If you understand these three levels clearly, many application-based questions become very easy. Now, let us see why biomimicry is becoming increasingly important. It helps create better products, processes, and policies. It enables new way of living. It improves performance. It reduces material and energy consumption. It minimizes waste. It solves human problems sustainably. It even creates new employment opportunities. But theory alone is never enough. Now let us look at some exciting real-world application. In biomedical engineering, researchers developed nearly a painless needle inspired by mosquitoes. The nature inspiration for this painless needle is mosquitoes. Mosquitoes proboscis pierces the skin with minimal pain and tissue damage. Here, the design and materials are microscopic features of the proboscis are studied. Proboscis are the stings which mosquitoes inject in our skin. Those are called proboscis. Proboscis. These are replicated and designed in needle form. How this work is that these needles vibrate and go inside the human skin. Without these vibrations causes no damage to the human tissue. So this results in minimizes pain, reduce tissue damage, and improves patient comfort. Scientists also studied sun slug slime. The mucus produced by the slugs is extremely sticky, strong, and stretchable. Inspired by this property, researchers developed surgical glue that attach effectively to tissues and potentially reduces the need of stitches. Another example is development of bionic arms, legs, and eyes. These technologies help restore lost human functions and improve quality of life. 3D printing technologies are also increasingly used in biomedical applications, allowing customized solution for patients, whether it can be teeth, skull, or tissue, or any vagera, it can be designed using 3D printed bones. Now let us move to non-biomedical application. One fascinating example is self-healing concrete. Certain bacteria can help repair cracks automatically, increasing the durability of structures. Let us go to the self-healing concrete very in depth in the next video lecture, which will be very interesting. So don't miss it. Please do subscribe. Nature. Now let us continue. Nature has also inspired antibacterial and low frictional surfaces, helping create systems that move faster with less noise. The Lotus inspired self-cleaning effect has influenced products that can stay clean without detergents. Another amazing phenomenon is iridescence. Many organisms produce brilliant colors without pigments. Instead, microscopic and nanoscopic structures manipulate light, creating colors that change when viewed from different angles. Butterflies are the classic example. Tiny structures on their wings scatter light and even help absorb heat. Nature has also inspired architectures. Finally, a famous example is the DNA tower. Its design is inspired by the double helix structure of DNA. The twisting architecture provides stability, occupies less space, offers panoramic views. That means wide range of views with different sides and performs better against strong crosswinds. So when we look carefully, we realize that many modern technologies are actually lessons borrowed from the nature. The future of engineering is not just about building new things, it is about learning from nature proven solutions and adopting them intelligently from human needs. And that is the true essence of bio inspired design. So, today we discovered how nature inspired everything from cars and buildings to medical devices and advanced materials. We have learned that nature is not just something we observe, it is actually a giant engineering laboratory that has been testing successfully designs for billions of years. And when engineers carefully study these natural systems, they can create smarter, stronger, and more sustainable technologies. But now think about this. Whenever a crack develops in a concrete building, bridge, or road, engineers usually need to repair it manually. What if the concrete could repair the crack on its own? What if a damaged structure could heal itself the same way our skin heals after a cut? Sound believable, right? Well, nature has already shown us how self-repair works, and engineers have successfully borrowed that idea. In our next lecture, we will explore the fascinating world of self-healing concrete, where tiny living organisms act like microscopic repair works inside concrete structures. Trust me, this is one of the most amazing real-life example of biomimicry that frequently appears in examinations. If you enjoyed this lecture, make sure to like, share, and subscribe to the channel. Also, comment below and tell me which biomimicry example amazed you the most, whether it can be bionic car, gecko tape, DNA tower, or self-healing concrete. Thank you for watching.